Hello, everybody, and welcome to this wonderful Tuesday afternoon. And yep, crawling to the end of October. Got to go back on Sunday. Oh gosh, all sorts of things happening. But first and foremost, we've got a wonderful business spotlight interview today. We've got Sid for Concrete for Change. This is going to be very interesting. Sid, tell me all about the business.
Okay, thank you, Tim. Hello, everyone, all of your audience, and my name is Sid. I'm CEO of Concrete for Change. So, regarding my background, I'm a civil engineer by training. I did my PhD at Edinburgh around 10 years ago. I'm from that time working in both academia and industry. The business Concrete for Change. So basically, if I start from problem statement, right now, 8% of global emission coming from concrete. If we continue business as
So could I
usual,
just jump in there? What percentage?
8%.
8%. Eight
Correct.
percent from concrete.
Correct.
Wow.
So it's mainly from production of 4 billion tons of cement responsible for 3 billion tons of CO2 emission. And if we continue business as usual, by 2050, we are and limit global warming somewhere around 1.5 till 2 degree. By 2050, industry consumes something around 40% of carbon credit. So industry is significantly, basically is contributing to global warming and emission. And there are a few limited ways to reduce the emission, and we are trying to develop one of those net zero pathways. So technically, the option industry has is using a kind of supplementary material, which are the waste of different byproduct of basically different procedure, which right now we are reaching to the threshold. We are utilizing 100% of them. They know as SCM, supplementary cementitious material, or right now in the UK, we are importing them from China. Or we can use what is known as carbon capture and storage, which means that we capture the CO2, then pressurize that, then purify that, then liquidify that, and then transfer that somewhere and inject that underground, which can increase the cost of cement around 3 times. And cement is the most used, basically manufactured material on Earth, or the second consumed material after water. So tripling or the price of concrete will be a meaningful effect in our day-to-day life. So it's really important to consider that part. Or we can use the CO2 in order to develop new product and valorize the effect of basically this emission and basically convert this challenge or this problem for global to a kind of opportunity. And we are trying to take advantages from that part and convert this problem to a solution, basically.
Right. And how are you doing that?
So concrete is potentially it can absorb CO2, a significant amount, around 30% by the weight of cement. And this is one of the safest thing for CO2. So technically, CO2 will react with different element in concrete, mainly calcium, and it will be permanently sequestered. We should heat concrete up to 1,000 degrees to release that CO2 to air. So if you crush that or whatsoever happening for concrete, CO2 is still locked up. The problem which naturally happen is this potential never will be fulfilled naturally because of different limitations. CO2 from air cannot penetrate more than a few centimeters in concrete. You need a specific temperature, you need a specific range of humidity. Normally, concrete member will be covered or basically buried underground, so they are not exposed to CO2 for duration of procedure. And I think the most important part, duration of carbonation naturally is somewhere around 100 years, centuries, basically.
That's amazing. So in terms of the process, you take the CO2, which is emitted from the manufacture of concrete, and you put it back into the concrete itself to capture it.
Correct. Sorry, I didn't explain your previous question completely. So what we are doing is accelerating this carbonation procedure from hundreds of years to less than 100 hours, or somewhere around 100 or a few hundred hours. And because we can provide a uniformly mixed CO2 with concrete, concrete has enough time to absorb all of that and convert to a stronger version of concrete. And this is really important. So basically, when we are mixing cement with water, we are developing different ions that shortly after 12 hours, they will develop different species in concrete, which are different crystals. So it is really important at what moment, how much of CO2 is released, because CO2 at any basically a period of time will basically react with the available ions or available species. So it can result in different products. If we introduce too much CO2 too early, we will reduce the basically strength and durability of concrete significantly. I think the key point which we are working on, that is a very release rate of slow for CO2, which is uniformly mixing concrete, and that reached to our unique selling point, which is using a series of carrier. So basically, we are taking different waste precursor. Let's say organic waste like lignocellulose product, inorganic waste like basically silicate-based product, or basically polymeric waste, and then develop a new, basically transfer them to adsorbent that can mix with, that can absorb the concrete, and then this new species will be mixed with concrete.
Right.
When they are, so they can absorb the CO2, they will be mixed in the concrete, and when they start to releasing CO2 by different basically triggers in concrete, because concrete is really hostile environment and break down a lot of products. So this CO2 will be really uniformly available, because this is the fine powder mixed with the concrete when it's wet, and we can control the release rate of CO2, and we can control how much, what is the quantity of CO2 we are mixing with concrete. Because we have control over these two elements, how much CO2 at what basically time is releasing, we can exactly target that, what species we like to carbonate technically. Carbonation means that react with CO2. So we can define what species we like carbonate, and if this procedure is done properly, because we have 1,000 ways which can go wrong, or a few ways that are right. So if we do it in the right way, then we can densify the concrete, which result in a concrete which is stronger, which result in a concrete which is more durable and has less porosity, basically.
Fantastic. Well, thank you for explaining that. It's pretty technical, but how did you come across this? I mean, it's sort of obviously you've been researching this for a long time, but what was the idea behind it?
I guess I know concrete for like 25 years, and we are always, as a civil engineer, we are user and abuser of concrete. So just during COVID time, I was just reading about concrete, and it was amazing for me. And those days, the global problem wasn't as famous as it is these days. So it was 8% of global emission from concrete, and it was really shocking for me that, okay, 8% is a lot. And I was just looking for a solution to reduce this emission. And it happened that all of project I've been involved from 20 years ago as a charter civil engineer, was around environmental friendly, basically construction. So it was really important for me to see if we can reduce this emission, and then different parts of this business model came together, working with different people and basically learning from different domain experts. So it was like, okay, can we develop a product from CO2 which doesn't need to change the manufacturing part of concrete, because that's really it's really expensive to develop infrastructure, and industry is really conservative, doesn't like change. The answer is yes, maybe we can develop something that work like admixture, so we don't need to change the main procedure. So then the question was, can we define a product that won't drastically change the effect, basically cost of concrete? And the answer is yes, because we are increasing the strength of concrete, we can reduce the amount of cement in concrete. And cement is responsible for 70% of cost and roughly 70% of emission of concrete. So it's like elephant in the room. If we are using less cement, so cost will be cheaper, or even level, be it conventional concrete. So it's really big incentive for the industry. And the final question was how much we can be cleaner. And I think our value proposition coming from two folds. The first fold is like a CO2 removal by injection of CO2 into concrete and sequestering that. The second fold is by material removal, because we can use less cement. Concrete is stronger, so we need less binder. When we are reducing amount of binder we are using in concrete, we are reducing both cost of production of concrete and emission of concrete.
That's absolutely fantastic. So, what's the industry saying about this? What are they? I mean, there's lots of big players in the industry. Are they really interested in this?
I think it's the mixed signal. Obviously, industry is under pressure to reduce their emission. Regulatory are pushing through a lot of carbon credit they have for emission, especially in cement industry is reducing. The price is drastically increasing like 10-20% per year. And a lot of players are genuinely interested in reducing their emission. And I guess industry is pushed by all of this regulatory and basically public part to reduce their emissions. So I would say industry understandably is really conservative because they have a really low margin and is a mass production basically of product, which should have very consistent result. However, I think they are embarrassing this change, and they are happy to accept this, basically all of this new innovation and change which coming to this old industry which they used to run for a good while, like in the same way.
Yeah. So it's just a matter of time and getting used to the change to embrace this technology.
I think you're right, and in the same time, a part of industry is private, which are fairly agile. They really are open to innovation. They utilize innovation to develop their growth. They are really welcoming and open about any innovation, including us. Some part of industry is a bit less agile. I think big incorporation, they would like to see more statistically significant basically outcome before join any venture, and they need a bit of more like time to adopt the technologies. Yeah,
Absolutely brilliant. So the challenges for the business going ahead is the education and obviously the market's there. So what do you think is the main challenge?
I would say our main challenge, how I define our position as a deep tech startup is basically we have a lot of studies, a good studies and science in university, but generally those science are done by this perspective of science for the basically sake of science. So the outcome of that science necessarily shouldn't be a new product or industry. It should be like a scientific output in a lot of these projects that university is doing. And there is a gap till you reach to the industry, which are really pragmatic and they like to take something and a few months transfer that knowledge to a product. So there is a big gap. A lot of people call that like a Death Valley, which is the gap between academia and industry, how you take science and transfer that to a pragmatic product that can be utilized by industry. And we are within this Death Valley. So we are taking different technologies and transfer that to product. I think the main challenge in this part is we are too agile for academia and too demanding because we are looking for result, not just the sake of running some science. And we are a bit like slow for industry because it takes a few years to reach the product, while industry won't like necessarily invest in the business that won't make any profit or any meaningful result for 2 or 3 years. So that's a bit challenging, like that, filling that gap and being a deep tech that should run the business for 2 or 3 years before having any basically tangible result that the industry can feel and try that.
Absolutely fantastic. Thanks for sharing. This is absolutely fascinating. So, what does the future like? What where do you think it's going to go?
So I think if generally speaking from about future, I think we have to not as a company but as a human being, we have to find a lot of these solutions if we like to tackle the global warming, and that's the core value for our people. I would say our team, regardless if it's Concrete for Change or any other company. And as a company, I would say we have done a really big progress. We are very close to the market. We have a few products that, yes, they are not finalized. Still, we have some variation in our product. Still, we should pass regulatory parts of that. Still, we should finalize the product. But for the first time in the history of, I would say, industry, we develop a product out of CO2, synthesizing from CO2, which can mix with concrete in a very limited quantity, let's say 10 kg per 2 tons of concrete, 1 cubic meter, and it can change the property, especially mechanical property of concrete, just significantly, like 10%. So basically, we can inject CO2, increase the strength of concrete, and then we take all of those value proposition we discussed about that, reducing the cost, reducing the material we are using. I think our main role will be just showing this, because a lot of big players tried that and failed and they left that it is possible that synthesize different product out of CO2 and put that in a concrete which have positive effect in concrete. And that's one of the best way to basically store and utilize CO2 as a product, basically, because we are using a significant amount of concrete in the world.
Brilliant. Oh, fantastic. Well, Sid, thanks so much for your time and thanks so much for sharing that with us. I mean, it's absolutely fascinating, and I'm sure you're going to get some reaction. I'm still trying to take it in, and I've had a chat to you for a good half an hour, 40 minutes prior to this. But thanks so much for sharing it, and
Thank you.
we need to do it. It's as simple as that. Absolutely fantastic.
Yes, you're 100% right. I would say we have to do that. So hopefully we will be one of those meaningful change in the world, which we can do that. Yeah.
Brilliant. Thanks for your time.
Thank for your time.